What's your question again?
I shifted into the zero momentum frame.
Okay.
In this frame, the 4 kilogram mass has a velocity of 6 meters per second. The 8 kilogram mass has a velocity of -3 meters per second.
Yeah.
From an energy point of view, it has a speed of 6 meters per second. It has a speed of 3 meters per second.
Okay.
I want to know so they're gonna collide.
Mm-hmm.
My kinetic energy needs to stay the same. My total momentum needs to stay the same.
Okay.
What would be a value for those velocities so that that is true?
So you need to find velocities when it stays the same as in 10 and 1?
No. As in my momentum is still 0, and my kinetic energy is still whatever the kinetic energy is.
But why isn't it, so you're saying what is the velocity to,
When
The-
momentum stays the same and kinetic energy stays the same.
Yes.
I understand that much, I just don't know the formula.
okay, but you're saying that the final momentum stays at 0?
Yeah, I'm in the zero momentum frame here,
So why isn't it just like 6 and -3?
because they haven't collided then.
Oh, so you're saying when they collide.
So we have to do the first equation.
It's simpler than that.
Second equation?
No, wrong track. I thought Moran was about to get it, but
No, like I feel like I know.
all of you know. If I said it,
Shouldn't we just do the V and 10 minus V and whatsoever
number,
that's on the
right?
bottom?
The answer's a number?
yes, the
So
answer,
is the answer 1,
no.
2, 0?
There'll be 2 numbers.
It's 2 numbers, so 2
Yeah, because
different
each has its own velocity.
Okay,
So don't we just do where it's the fourth row on in blue?
That's how we figured out that that we needed to subtract 2 from each side, that we've already done that,
So then we need to do the previous ones,
the previous one.
the previous blue rows.
No,
it's 3.
Don't we just subtract?
not for this next step.
So, I understand what you're asking, but I just don't understand why are you saying these are not colliding? Like I
No, you gave me an answer of 6 and -3,
Okay,
which are the velocities in the zero momentum frame
okay.
before they collided.
So if
If you give me the exact same numbers,
Mhm.
then you haven't changed the problem at all. There's been no collision.
What did they?
Do we need to find out when the collision is? Or like,
Oh, is it just? Oh, I don't know. I don't think that is right. So
momentum and
if
kinetic
they're
energy
going
stays
at 6 meters per second, well, if the first mass is going at 6 meters per second and the second mass is going at -3 meters per second, you're saying that they'll never collide? No.
If this is 6 and -3, they have not collided.
So they have not collided. Okay. So what?
If I take a ball
Wait.
and I drop it and it bounces off the floor and comes back to the original height, we have a perfectly elastic collision with the floor. So if I drop the ball and it's going at 10 meters per second just before it touches the ground, how fast is it going just after it touches the ground?
like perfectly inelastic?
No, if perfectly inelastic, it'd be going 0. Perfectly elastic, it's gonna bounce up back to the same height from which I dropped it.
Would it
Negative
not be
value?
faster because it reflects?
Uh,
No, it wouldn't be because then it has to slow down.
It'd be the same. Is it just opposite? Is it just like -6 and positive? Okay, see, no, my issue with that is that makes no sense. I was gonna say that, but that does not make any sense to me.
The speeds are still the same, so kinetic energy's gotta be the same. This has the same speed, this has the same speed. The speed did not change for either of them before and after the collisions.
Okay,
So kinetic energy is the same. My momentums have flipped,
okay.
so the total momentum is now -0 instead of +0.
Oh, and that's not a thing.
Yeah, negative and +0 are equal to each other. I remember doing a proof in high school.
No, like, I get we would just have to flip the signs, but I don't understand why does the second one mean like that they're colliding and the other one isn't? That's what I
Because
don't
their
know.
velocity changes, so there has been because the velocity changed, there's some acceleration, which means some forces apply, which happens when they collide.
Oh, wow.
So we have the collision, this is still the zero momentum frame. We need to shift back into the original problem. If you left this as a final answer, it is not correct, because you do need to put it back in the original form. So we're gonna shift back. Shift back. So I subtracted 4 to get out of the lab frame. I need to add 4 to get back into it. And I end up with -2 and 7, which is the answer that we got the last 2 times.
Would,
You'd be testing us on this, or can we just do the previous 2 methods?
Sorry, I'll address that in a moment.
no, I understand. I understand.
All right, the advantage of this method is it is a whole lot simpler. The biggest bit of math that you're doing is figuring out what this number here is. The disadvantage is more abstract. So you have 3 different methods for solving the one-dimensional, perfectly elastic collision. As I mentioned before, there will be a question on the test where there is a perfectly elastic one-dimensional collision. I do not care which method you learn. Learn one of them and use that one. The biggest problem where the students run into on the test is, one, it appears like they weren't expecting that question on the test, even though I said it on multiple occasions, there will be a perfectly elastic collision question and a perfectly inelastic collision question. And 2, people who mix and match methods. So pick a method, learn it, live it, love it.
Is this a test level problem? I would guess not.
Yeah.
Oh, that's a test level problem.
Yeah, I mean, the velocities might go in the other directions, but yeah, one-dimensional, 2 objects heading towards each other, or one's pursuing the other one. There'll be collision. They will have velocities different afterwards for the perfectly elastic collision. Solve it.
Okay.
Okay. Now, another question, doesn't have to be answered now, is for the test level problem, do you want the answers to be integers, finite numbers, or just random numbers that will actually ultimately be a fraction, so they'd all be rational numbers, but not necessarily finite? Do you want the final answer to be integers or not? Now, the advantage of knowing that they're gonna be integers is that if you get integers in your final answer, you could feel like you've done something right. The disadvantage is if you solve it and don't get integers, now you're left with a quandary of, uh-oh, there's a mistake somewhere. How much time am I gonna spend trying to track it down?
I like the option of having integers.
All right, we have 1 vote for integers, the rest of you can speak now or speak later.
Integers.
Whatever you guys want.
It's either wrong or possibly wrong. I prefer it at least be possibly wrong.
Oh, wait, on your practice test that you publish on Blackboard, are the answers to the perfectly elastic questions integers or the
It depends.
What exactly is a finite number? Just a number that doesn't terminate? Or that does
Yeah.
terminate?
That does terminate, like 4.5.
Yeah, not like pi, or like
Correct.
Euler's number, or whatever that is.
Or something that ends in a 1/7. It repeats, it's rational, but it doesn't stop.
1/6 is pretty bad too.
All right, what I wanna do now is I'm gonna put up a problem,
and we should put ourselves.
pick one of the methods, and I don't care which one you do, pick one of the methods, use it. And, because I have answers here with, oh, that's near integers. Here we go. These are integral answers. 4, 6, negative 1, 10, 4, 6.
Are we allowed to work with partners?
Yep.
But this is just
All right.
What's your favorite method?
I prefer method 3 personally,
I agree.
because I find that the simplest. However,
Can you,
each to his own.
can you help me with method 2, because I didn't finish it, I got caught somewhere. I got caught right after this.
I'm going to pause this and pretend I'm going to remember. All right, let's talk as a group here. Method 1, you've got, this is the conservation of momentum equation here. The biggest mistake I saw walking around were people putting down 1 meter per second instead of negative 1 meter per second. Or if you want to make the other direction positive, that's fine, but these two are in opposite directions, so one of them is positive, one of them is negative. I assumed to the right is positive when I did this, so. Oh, actually, that one also, and that one also. So this is my momentum of the 4 kilogram mass plus the momentum of the 10 kilogram mass is going to be equal to the total afterwards. And then kinetic energy is going to be conserved, so we have, that's 72 plus 5. So total kinetic energy is 77 joules. Afterwards, for a perfectly elastic collision, 77 joules. So 2 equations, 2 unknowns, solve for L or Q, plug into the second equation, and have fun. Method number 2, we still have the conservation of momentum equation. That is the same as up here. The only other difference is the relative speed of approach, which is the difference in the velocities, is equal to the difference in velocities sign flipped. So this was the 4 velocity minus the 10 velocity, and afterwards 10 velocity minus the 4 velocity. And then in the third method, the biggest math you have to do is figuring out the center of mass velocity, which is 1 meter per second. So when I shift, I'm going to subtract 1. So we have 6, negative 1, subtract 1, subtract 1, 5, negative 2, flip signs, shift out, negative 4, and 3. And then don't forget units in the final answer. This is why I personally prefer the third method. It's just easier to write it down, but there is some leaps of faith here.
I have 2 questions.
Yes.
Well, on a quiz or a test, will we ever be forced to use a certain method?
No.
Or do we always get the option? Okay.
Get
And
the
then, and every single time I use method 3, if I were to do all the work correctly before, when we're trying to find the center of the mass, it's always just flipping the signs.
When you shift back,
Yeah, like, will I always have to, you know how like we just changed the sign 5 to negative 5? Will it always be that way?
oh, yeah, at the collision, all you're doing is just flipping the velocities, keeping the speeds the same.
Got it, perfect. That's fine.
All right?
That's only if you use method 3 though?
Yes,
Okay.
that's correct. And in a class of 24, about a third will choose method 1, a third will choose method 2, a third will choose method 3.
You had 24 students in a class before?
Okay.
Okay.
There was a time in which there was just one section of 251 and one section of 151 offered in the fall, and in the spring, one section of each. And there were several thousand more students at the school.